Good morning, everyone. Welcome to the webinar series of Managing Drought in the Southern Plains. I'm Mark Schaefer with the Southern Climate Impacts Planning Program. I will be the moderator for today's webinar. Margaret Boone, Skip Program Manager, and Rachel Riley, Associate Program Manager, are here managing the webinar with us. Today's webinar topic is What Happened to El Nino? Brian Fuchs, climatologist and drought monitor author at the National Drought Mitigation Center, will begin with an update on the current drought status and outlook for the next several months. Brian will be followed by Victor Murphy, Climate Services Program Manager at the National Weather Service Southern Region Headquarters in Fort Worth, and Klaus Wolter, Research Associate with the Cooperative Institute for Research in Environmental Sciences at the University of Colorado in Boulder. We have several state climatologists on the call as well to talk about some of the more local changes within our region. This is part of an ongoing series made possible through the support of several organizations, including the National Drought Mitigation Center, National Integrated Drought Information System, and NOAA Regional Climate Services. We also greatly appreciate those of you who join us in this webinar series and recognize the valuable time you commit to participating. You may ask questions or make comments at any time through typing in your chat box. We will address questions at the end of the presentation. Each webinar is recorded and posted on the SCIP website, southernclimate.org, or on YouTube. Summaries of these presentations are also posted on the SCIP website in the publication section. You can also friend us on Facebook or follow us on Twitter using @skip_RESA. I will now turn it over to Brian for an update on drought conditions and outlooks. Brian?
Thank you for the introduction this morning, Mark, and again, hello to everyone. What I'm going to do is go through some of the U.S. Drought Monitor products, looking at how conditions have progressed in the region. Going to look at some of the climatological indicators that have been popping up here, and then also a couple slides on the outlook going forward over the next few weeks, and then even the seasonal drought outlook that was released last week. So, first slide. Here is where we were back in August. You can see that there was a fairly large footprint of drought at this time over the U.S. In the southern plains, we were seeing most of the extreme and exceptional drought in Oklahoma, and then into some of the neighboring states like Arkansas and Kansas. Go to the next slide. Here's where we were during the last call. Early September, we were seeing that footprint actually grow. We peaked out this year about the third week of September, where we were right at 66% of the U.S. in drought. And so if you think about where we are here on this image and progressed a few weeks, we started seeing some improvement in the eastern areas of the Corn Belt, but then that drought really started to intensify and spread to more of the northern plains and central and northern Rockies at that time. So even here during the last skip call, we weren't seeing the largest footprint of drought that we'd seen for the summer. Next slide. Went into October and we started seeing more of that footprint of extreme and exceptional really spread itself from Oklahoma up into South Dakota, with some pockets in Texas and other areas, but you could really start seeing that core of drought area in the region. And then as we go to the next slide for November, here's the latest map that was released this morning. And again, we're seeing some of those areas of north central Oklahoma into Kansas and into Nebraska, where really have not seen much in the area of relief at all over the early part of the fall so far. I know there was some good discussions on the U.S. Drought Monitor list this week that Gary McManus was talking about some of the winter wheat in the areas of north central Oklahoma and into Kansas, and I think winter wheat as a whole has really gotten off to a bad start in most places, just because the lack of soil moisture and the emergence of the crop has not been very good. So that's something that we're already going to be dealing with moving into 2013. Next slide, we're going to look at some of the stats from this week. It looks like my circles were offset a little bit, but we're right at looking at the current drought situation. We're under 60% right now, about 59.48% of the lower 48 in drought. And with that, only about 6% in D4, which is a stark improvement from a year ago, where we were seeing almost double that for the lower 48 with almost 9% in D4. Go to the next slide. This was, again, the region back in August. We can see definitely the D4 in areas of Arkansas, Oklahoma, and Kansas really standing out at that time. We had seen quite a bit of improvement in portions of East Texas and into Louisiana at that point. And then some pockets of dryness were still standing out through the region that we were looking at back in August. And then we'll go to the next slide. In September, which is the last skip call, we were looking at about 84% of the region was in drought still, so still a high number, and about 15.25% in D4 at that time. And you can really see where those areas of eastern Oklahoma through the Panhandle and into Kansas were really where we were seeing that core area of dryness really starting, or not starting, but continuing to intensify and really hang on. Even at times when we did see rain during this period, a lot of times it wasn't even enough to show a lessening of the intensity. So I'll go to the next slide, which is today's product for the region. Currently we're at almost 11% of the region in D4 drought, 75% of the region in some level of drought. Compared to a year ago, we were at 93% in drought and 41% in D4. You can say, wow, this is a big improvement, but if you look at the conditions and the impacts through the region, yes, the numbers are better, but the drought situation going into a multi-year event, now year 2, and we're going to progress into a year 3, really doesn't bode much for that conditions have really improved. I think there are pockets of the region that, yes, we can say conditions have improved and a lot of the drought impacts have been eliminated, but overall, when you're looking at 75% of the southern plains region in drought, and if you throw in the abnormally dry, that jumps up to 87%. There's still a lot of concerns in the region that we're going to be addressing moving forward. Next slide. One of the indicators that we tend to look at quite a bit is this NL-DAS soil moisture model, and I think it's doing a fairly good job, especially on this total column percentile graphic, of showing the areas where soil moisture has been really depleted down to the furthest depths. And you know, being in Nebraska, we've been hearing a lot about this, but it's not isolated in our state. You can go into the Dakotas, into Kansas, Colorado, New Mexico, Oklahoma, the Texas Panhandle, and even other parts of Texas. You can see that for that full soil column, some of those percentiles are really down in that 5 percentile range or even less, down in that 2 percentile range. And when you start talking about available moisture for pasture rejuvenation and soil moisture conditions, or excuse me, winter wheat conditions, this really starts telling the story. And we've thrown in there some of the warm temperatures over the last month or so too, and that just continually takes away that moisture from the ground, and we've been seeing that in some of the weekly NASS reports as well. The next slide. Here is the VIC model from out at the University of Washington. I kind of highlighted this region here. It really is focusing on some of those areas where we're seeing that soil moisture being depleted, and then from the ground reports that we're hearing from these areas as well. This area seems to line up quite well with some of the reports that we're hearing, especially for ag-related impacts and even some of the ranching-related impacts where grass and water are still short for many of the producers in those areas. Next slide, please. Looking at stream flows, and you can start to see typically what we're looking at is the darker red and brighter red circles here. And this is a 14-day average, and so you are going to see some fluctuations, and there are some management conditions that are involved in some of these areas as well. But you can see all the way from Nebraska through central Kansas into Oklahoma and Texas, and then even to the west into Colorado and New Mexico. There's some hydrological problems, and to me that does not seem too unsurprising because it is a multi-year drought through much of that region. We are going in almost through 2 full years of drought conditions through this region, and going into a third as we're going to see this drought persist. The next slide is more of a regional perspective. You can really see some of those areas, especially coming out of eastern New Mexico and western Texas, central to western Kansas and Oklahoma. There's quite a bit of a deficit here as far as the flows on the rivers and streams that we should be seeing for this time of year. Next slide. And here we are looking at some of the ACES products coming from the regional climate centers. The upper right panel is the 30-day ACES departure from normal precipitation, and just over the last 30 days you can kind of see that through East Texas into Louisiana, pushing up across the Red River into Oklahoma, we're looking at deficits anywhere from 3 to 4 inches, even greater in parts of East Texas and Louisiana, and pretty common deficits of 2 to 3 inches through the region just over the last 30 days. And you couple that with some of the heat that we've been seeing still into October and November, you can see where those soils are continuing to dry out. The 60-day ACES departure from normal, you can see that through central Texas and into portions of western Texas and into the panhandle of Oklahoma as well. Some of those departures are actually positive for this time frame, where we had picked up some decent rains, but then you can easily see also where the deficits are maintaining themselves, where 4 to 6 inch deficits over the last 2 months is fairly common. And then if you go into portions of East Texas into Louisiana, those deficits jump up into that 6 to 8 inch range. So by any means, we haven't seen this widespread relief over the last 2 months. Next panel. Year to date in the upper right, we're looking at the same departures, and again, you can almost see that area across central Texas into Louisiana where the heaviest rains we're seeing earlier in the year, where we see positive departures anywhere from 5 to 10 inches in portions of Louisiana, and some of that is also related to some of the tropical events we've seen along the Gulf Coast. But then as you go into northern Texas and southern Texas, 5 to 10 inches is, for deficits, even 10 to 15 in places, and actually worse as you get into portions of New Mexico, Oklahoma, and into Kansas, where those departures just for the calendar year are in that 10 to 15 inch range. And then the last 12 months is highlighted in the bottom left, and more of the same. We see those deficits continue to climb as we look at the last 12 months, anywhere from 12 to 16 inch departures in portions of eastern Oklahoma and southern Texas, and widespread anywhere from 4 to 12 inch departures over a lot of those areas, and even 4 to 8 inch departures in areas that have seen some fairly decent drought relief and precipitation through those regions. So again, what we're seeing is this continual dry pattern now going into a third year. Next slide. Just briefly looking at some of the SPI numbers on both the 30 and 60 day. You can see those areas in the 60-day down in the lower left where we have seen those precipitation events going across Texas and into Louisiana and Arkansas, and then also in through the panhandle of Oklahoma and Texas and into extreme southeast Colorado. On the 60-day, on the 30-day, you can see where some of those signals have not yet been improved upon. Next slide. Looking at the outlook now, over the next 5 days, we're going to see quite a bit of transition through the region, quite a bit of warm-up here over the next few days, and then the bottom's really going to drop out. You can see with the temperatures, we see a good punch of cold air that's going to be making its way associated with a fairly vigorous trough that's going to move across the country starting over the weekend. I think we're going to see it here in the Central Plains as early as Saturday night, and then in the Southern Plains, I think it's going to be more into Sunday. But associated with that, it doesn't seem to be a big rainmaker, as can be seen on the lower left-hand panel. We're anticipating some precipitation, but it's really going to be more to the eastern edges of the region, maybe catching eastern Oklahoma, eastern Texas, Louisiana, and Arkansas into Missouri. But some areas are not going to see much out of this at all. So a big shift in temperatures. It looks like later next week they are going to moderate a little bit, but we are going to get a good punch of cold air coming out of Canada here. Next slide. The 8 to 14 really reflects this. You can see with the temperature profile on the upper or the right-hand panel, even after that cold air punches in, we're going to see things moderate again 8 to 14 days out, with most of the country seeing high probabilities of seeing above normal temperatures during that time. And again, the precipitation over the next 2 weeks through much of the region, we're going to be looking at normal to high chances for below normal precipitation from Nebraska all the way down to the Texas Panhandle. So a lot of the precipitation, again, coming up with this event is going to be more to the north and to the east of the Plain States. Next slide. Here's the seasonal outlook here, looking at November 1st on the top 2 slides. Again, the odds of above normal temperatures are fairly high, especially in the desert southwest and as you propagate out from that region through much of the Plain States. And precipitation associated with this time frame in November stays fairly equal chances to below equal chances of normal precipitation during this time, as the precipitation seems to be locked in to the northern states, or at least the best chances of above normal precipitation as we interpret this. Then the seasonal from November through January, more of the same. We see that above normal chances of temperatures above normal through much of the Great Basin and Rocky Mountain states into the central and southern plains. And precipitation looks to be equal chances. I know we have others that are going to be speaking of the El Nino that was, and so I'm not going to touch too much on that, but you can see that equal chances where a few, 6 to 8 weeks ago, we were looking at above normal precipitation chances along the Gulf Coast all the way into Texas, and that's kind of been whittled down a little bit. Next slide. And the seasonal drought outlet that came out last week is, excuse me, this is the one for September. I'm sorry, I was going to give a little overview. This was the one that came out right at the time of the last skip call, and we were looking at those improvements over the central and eastern Corn Belt up into the northern portions of the Midwest, and then the monsoon signal was still fairly strong at that point. And going to the next slide is the most recent. We see that the signal from the monsoon kind of go away, and we don't look for a lot of improvements through that region, some improvements through California and into Nevada. But it looks like, for the most part, the areas that are in drought all the way from South Dakota down to Texas westward are going to persist in drought, not only through the next several weeks, but also over much of the early part of winter. Again, that wet signal that the improvements are being shown over the northern plains and into the upper Midwest, that's really associated with the system that we're going to be seeing moving through here over the weekend. And so, you know, we look at this persistence signal, which has been strong now over the last several releases of the seasonal drought outlook. Really not much going into winter that's going to be changing the overall drought status, not only in the southern plains, but in the central plains and Rockies and into the western U.S. Next slide. Again, my contact information is listed. You can email me or call me if you have any questions. And I should be around here at the end of the call if anyone has questions for me then, or if you want to take them now, we can. That's your call, Mark.
Okay, thank you, Brian. I don't see any questions on the chat box, so we'll move on into Victor's going to tell us a little bit about what's been happening with El Nino. So turn over to Victor.
Yeah, hi, Mark. Thank you, and thanks everyone for attending. My presentation, I'm just going to briefly talk about El Nino, La Nina, sort of why it matters, why it's important, and what we're looking at for right now in regards to late 2012 into 2013. Tell my presentation here, the Camino El Nino of 2012-2013, and I guess we'll see the reasons why I call it that as we move forward. Next slide, please. Real quick, I want you to focus here in that area there entitled Nino 3.4. That's an area along the equatorial Pacific Ocean between 5 degrees south latitude and 5 degrees north latitude that runs from about 120 degrees west to about 170 degrees west. Sort of a combination yellow box there and red box. The United States will be up in the extreme top right of this image. Bottom line is that scientists have documented a strong correlation between sea surface temperature anomalies in the equatorial Pacific Ocean, the region I showed there being that Nino 3.4, as well as attendant precipitation in the southern plains. So if we want to look forward in time, make a forward-looking forecast, say for 6 months to a year or so on future rainfall or future precip in the Southern Plains, one of the prime places to start looking at is the equatorial Pacific Ocean, this Nino 3.4 region. Next slide. In a nutshell, it's very common for the sea surface temperatures along the equatorial Pacific to sort of wax and wane or warm up and cool off, if you will. The image on the left-hand side is an El Nino event. You can see sea surface temperatures out there along the equatorial Pacific. The bottom left image shows the sea surface temperature anomalies. You can see anomalies up to 2, perhaps even 3 degrees Celsius warmer than normal. This is from one of the larger El Nino events from early 1998. Bottom right is the opposite. This is La Nina, one of the stronger La Nina events from early 1989. And once again, you can see how the sea surface temperature anomalies there were up to about 1 to 2 degrees Celsius colder than normal. So you can get, depending upon whatever mode you're in, you can get, absolute value anomalies of up to maybe 4 to about 4.5 degrees Celsius between warm events versus cold events. And as we know, these have a future impact on precipitation in the Southern Plains. Next slide. This image here is courtesy of Marty Hurley, who works for the NOAA Israel lab out in Boulder. And basically, there is a robust history in the October through June time period of in the Southern Plains United States between El Nino, La Nina temperatures in the December, January, February time frame and precip in the Southern Plains. In the top right, that area, that blue oval there, these are events in which the tropical Pacific sea surface temperatures are about maybe 1 to 1.5 degrees Celsius warmer than normal. And you can see a strong preponderance to have above normal rainfall in the Southern Plains for that October through June time period when we have warmer than normal sea surface temperatures. Correspondingly, or opposite, on the bottom lower left part of that graph, when you have sea surface temperatures that are about 1 degree or so, or 1 degree or even more colder than normal during that December, January, February time frame, you correspondingly tend to get, or have a very strong tendency to get below normal precip in the Southern Plains during the cold events. So the top right would be El Nino events, bottom left would be La Nina events, and as we can tell, strong tendency for Southern Plains to have above normal precip October through June during warm events, strong tendency for below normal precip during cold events. Next slide. Here's sort of real quick the reason why, in a nutshell, during the El Nino events on the top, we tend to get a real strong west to east jet stream that sort of runs, say, from the equatorial Pacific Ocean, sort of west to east across the Southern Plains. We tend to have a lot of wetness there in that green area from, say, Southern California, Arizona, New Mexico, eastward across the Gulf Coast into Florida. During La Nina events, which we've just had 2 of them, 2 winters in a row of La Nina, the jet stream tends to be more northwest to southeast and much drier for the Southern Plains. Next slide. As I said earlier, routinely, the sea surface temperatures in the equatorial Pacific Ocean, that Nino 3.4 region, very common to have them wax and wane or rise and fall with time. This image here shows that equatorial Pacific, that box there between 120 west and 170 west, between 5 degrees north and 5 degrees south. You can see since 1982 how we've had, El Ninos, La Ninas interspersed. If you look at the 1990s, there were several El Nino events, warmer than normal. Since 2000, we've had a couple pretty strong La Ninas. That would be the blue. Most recently, what you want to notice, the 2 La Nina events, 2010, 2011, and 2011-2012. The first event was more significant. It was colder than the second one. Not surprisingly, so the drought, if you will, corresponding to that first La Nina, which developed in mid to late 2010. A lot of Southern Plains got plunged into sort of the current drought that a lot of us are still in. That drought, by and large, began in October 2010 across just about all of New Mexico, Oklahoma, Texas, and to a lesser extent, Louisiana. We had a weaker La Nina last year, and extreme far right on the screen, you can see how for this year, we've actually bumped up into the positive or into the red, and the middle part of this year, July, August, September, we're actually running above normal sea surface temps out there, which was giving us great hope at the time that we would have an El Nino event this coming cold season, which in turn would provide a lot of the southern plains with drought relief. So this is sort of what we're looking at, say July, August time frame, late summer. Next slide. Look at this image here, looking from the top down. The most recent time on this image here is towards the bottom, and it goes back to December 2011. The colors are sea surface temperature anomalies. You can see at the top of the image there, December 2011, you can see how sea surface temperatures here in the central Pacific Ocean were running about 1 degree Celsius or so colder than normal. This is the La Nina of last year. Getting towards the middle of the image, May, June time frame, you can see how things sort of started reverting over towards El Nino, or we started getting some warming. That would be the light yellow colors. And then by August or so, you can see pretty yellows and darker yellows to even warmer temperatures, covering almost the entire central Pacific there between 120 degrees west and 170 west, giving us hope that we were on our way towards a El Nino event. A couple things to look at here. If you look at the temperature anomaly starting in August and coming downward through September and October, you can see there's actually hasn't been much change. In August, between August and September, temperatures are actually slightly warmer than what we are now. At the time, in August, September, we were thinking, hey, we're on our way to El Nino. More often than not, whatever phase you're in August, September, that's the phase you're going to have come that winter. You can see where we're at. All the models are showing us to continue to stay at that stage and perhaps even get warmer. Based on that, the NOAA Climate Prediction Center, or NWS Climate Prediction Center, issued an El Nino watch for this coming fall into the winter, basically saying, hey, we're going to have El Nino developing. Next slide. But you can see here, it's the same type image. You can see on the far right how this El Nino since September has sputtered. Looking at 2010, you can see La Nina bottomed out there about negative 1.5 degrees Celsius. The subsequent La Nina from last year was not quite as cold. We bottomed out about -1. But you can see the upward tick there on the right-hand side, sort of like the Dow Jones stock market. And you can see how we actually warmed up to about 0.5 to 0.6 degrees Celsius above normal by late summer, once again giving us great hope that we're on our way towards El Nino. But then starting in September or so, you can see how the El Nino started sputtering, and we actually cooled off from about plus 0.9 to our current conditions where we are right now of about plus 0.4. You can see how we just sort of been treading water, if you will, right around plus 0.4, plus 0.5 degrees Celsius the last month or so. In general, anything warmer than plus 0.5 would be a weak El Nino. Anything warmer than plus 1 or plus 1 and 1.5 would be a moderate event. So you can see how mid to late summer we were optimistic we'd have at least a weak event this cold season, if not a weak to moderate event. And quite honestly, right now, it looks like we're never going to have that. Next slide. And I'll let Klaus talk about that here after when I'm done. So bottom line is currently where we're at right now, the sea surface temperatures in that Nino 3.4 region have been holding pretty steady about plus 0.4 degrees Celsius, just below the threshold for an El Nino event. On the bottom right slide here, you can see how we actually warmed up to about plus 0.9 there in early September, late August, early September, have been sputtering and or treading water since then. So late September, a big drop-off in temps. October into early November now, not much change, just sort of sitting there right around 0.4 to 0.5. Good news is, looks like we're not going to be having La Nina this winter, which means the chances for below normal precip, I think, have lessened dramatically. But bad news would be, corresponding bad news would be, chances for an El Nino event have also decreased dramatically, which means our odds of seeing a wet winter or a wet fall, winter, and spring in the southern plains have diminished dramatically. Next slide. What does the future hold? This image here shows various different models. It's the most recent one available. And if you look at these various plumes, if you will, going from left to right, probably the thick yellow one's probably the best one to look at. That's basically an average law of dynamical models. You can see basically shows us staying, parked to neutral right around plus 0.5 or right around plus 0.4 into the springtime. This model is about 3 weeks old. There should be a new run coming out soon. I would suspect the new one will probably be slightly cooler, maybe 0.1 or 2.2 degrees cooler than this one here, which means we'll stay a little bit above zero, but not warm enough to be classified as an El Nino event. And like I said, CPC just today actually canceled their El Nino watch, which means they are not expecting us to be into a El Nino conditions this coming cold season. Next slide. Here's another image. This is from the International Research Institute in Columbia University. This just came out today also. You can see here basically the green bar graphs are ENSO neutral conditions. You can see basically the highest probabilities, basically 50 to 60%, call for us to be ENSO neutral into the spring and summer of next year, with only about a 20 to 40% chance of El Nino. 2 months ago, if I'm not mistaken, I think the El Nino probability was about 70 or 80%. That goes to show you how things have changed in the last 2 months or so. Conversely, the chances for La Nina are slightly higher. They were basically less than 5%, but as we move out towards, say, next spring or summer, there is an increasing odds for La Nina to occur. So, once again, bad news is I don't see no La Nina anytime in the next 3 to 4 months. So the odds of us having below normal precip are probably less than normal. But by the same token, the odds of us having El Nino and therefore getting above normal precip have also diminished pretty dramatically. And Klaus will touch upon that when I'm done. Next slide. So here's the takeaway message. With these ENSO neutral conditions now being more likely than not, impacts will be no strong signal on the probabilities of above normal or below normal precip for the southern plains for the upcoming cold season into the spring of 2013. Probably increased probability of increased variability. Instead of having to say a stronger signal for dryness or a stronger signal for wetness, we're probably sort of somewhere in the middle. And basically anything can happen: 1/3 chance of below normal, 1/3 chance of near normal, 1/3 chance of below normal. And this does lead to increased uncertainty for decision makers. If you're a water manager having to make decisions on, what do I do for this coming cold season, or what am I more likely than not to see as far as above normal or below normal goes, really tough to say right now. Next slide. And that's all I have.
All right. Well, thank you, Victor. And given the status that Brian talked about, I guess even a black cloud would give us some hope at this point. But there's not nearly the hope we had on the horizon a few months ago. Klaus is going to now tell us a little bit more about how this particularly affects and relates historically and to our region. So, Klaus?
Okay, can you hear me? Can you hear me?
Yep, we're good.
Oh, okay. I guess I have to tell you when to advance. So I took out the part where I was actually looking at the last water year, and I can send you those slides if you're interested on how this last water year stacked up against expectations because of a double dip La Nina. And we basically had this huge increase in drought coverage into the Central Plains, which is somewhat consistent with that whole historical trend. So there's a difference between the first year and the second year La Nina, but since that's not really on the table, I just took that out in the interest of time. So I'll talk about a little bit about ENSO. I'll probably keep that short since it has been covered twice now. I will talk a bit about other factors, and to me, other factors include CPC. So I will repeat a little bit of that just to show how the forecast has changed. The PDO, AMO will touch on that, and then also the NAO, which I think played a big role last winter in keeping Texas, for instance, wet. And then I will have what I have so far as a forecast. Next. So I would like to show this comparison for the observations in the Pacific. So this is the tropical band, 10 north, 10 south, from New Guinea on the left all the way to almost South America on the right. So this is a very big scale. And the top figure shows where we were at in July. And at that point, we saw +1 degree C anomalies. That's the second panel basically covering the eastern Pacific, and it was almost like a carbon copy or a classic onset of an El Nino that we are used to when you read the classic literature on how they used to start on the eastern border of the Pacific. So things look pretty peachy, and at that point, the coupled models had anticipated an onset of an El Nino, and so it looked like another success story for the coupled ocean atmosphere models, just like in 2009 when they caught that onset of that El Nino and the statistical models did not. So fast forward 3 months into early November, and we can actually see some negative contours now in the eastern part of the Nino 3.4 region there. That's that pink box I have. And let's just say that's not what you expect to see with an El Nino. So the conditions just for the last 5 days continue to show, on average, neutral conditions. These little arrows show the wind anomalies. The bottom panel shows these wind anomalies from the east. So those are enhanced trade winds, not a good sign. I'm not showing this here, but I looked at the intraseasonal activity level, so what we call the MJO, the Madden-Julian oscillation, and it's just coming around right now into the right area. And for instance, the daily southern oscillation index dropped to -18, which is a good sign. So there's still, this corpse is still twitching. We're not completely done yet, and what is really a key feature that could still bring back an El Nino, I'm not predicting, so I'm just saying that there is still the outside chance that this could happen, is the fact that we have very warm temperature anomalies right around the dateline and the equator. And if we were to get a strong intraseasonal oscillation to come and project onto the equator, and this time of the year they end up usually south of the equator, so we're this sort of, this might be the last chance, I would say, in the next month or so, where it might still project onto the equator, and because of the warm temperature anomalies, it could hang together a bit longer and march further east and trigger a Kelvin wave, which in turn, a few months later, could trigger El Nino. So I'm still saying there's a 10 to 20% chance that this could still come out of this. And my example for historical precedent for this would be 2004-05, which was a winter that ended up on average El Nino, but it had very weak phases in between where it was neutral by any standard, and then intraseasonal oscillations came around and bounced right back. So far, the intraseasonal oscillations have been pretty anemic. They have not shown any tendency to increase in strength. So again, maybe my 10 to 20% chance is giving it too much credit. But that's sort of the scenario where it could still come back. Next. So this is my favorite ANSO index. I noticed that a lot of people at NOAA still have trouble using it. It combines more than Nino 3.4 into examining what's going on. For instance, the 2010 La Nina in Nino 3.4 was only, like Vic said, -1.5. All other indices, including the Southern Oscillation Index and this MEI, showed a much stronger event. In fact, it was the strongest La Nina condition since 1975. So Nino 3.4 was a little bit misleading there. You can also see, especially on the bottom left panel, you can see how we had this premature event. The blue arrow points to the peak in June, July. So as far as I'm concerned, we had a very short-lived El Nino. The last time we had an event that peaked that early and basically died by the fall was in 1953. So I have these two analogs, 2004-05 in terms of an event that oscillated back and forth between neutral and El Nino conditions, and the fact that we now have 2 months in a row, the updated value there is 0.1 for September, October. That's a bad sign. So I think this 2004-05 scenario is shrinking in its possibility. But in 1953, we had an El Nino that had a similar structure of starting early, peaking early, actually by the middle of the year, and then being done. So this is not totally unprecedented, but pretty unusual, obviously. Next. Yeah, I like to show this. This was the year of big extremes. So even though the coupled models on average were showing this El Nino event, they kept carrying a lot of uncertainty. So the spaghetti plot from the European model, which is the best model in the business, showed some astounding ranges all the way into the summer. So even in July, it had a chance for what we would call a super El Nino of over plus 2 degrees C and a possibility of dropping back below zero into weak La Nina territory. So that was kind of a warning signal that the range remained high into the summer. And I guess the new one will come out next week, so we don't know yet what the November plume looks like, but you look at the October plume, and yeah, it's just weakly positive, and by January, February, there's quite a few members of the ensemble that drop below zero. Now, if we stay neutral, this is just a little heads up here, that means that the statistical models, which were predicting all along that we wouldn't see an El Nino, have the upper hand, which is a big turnaround. So statistical model skill is still they're still hanging in there. So the coupled models, as much as we celebrated a few years ago that they were ahead of the statistical models, they apparently are not infallible. Okay, next. And that was actually the figure that I meant to make that comment for. So this is the IRI plume, which just shows the averages of all the models. And I think Vic showed the right figure too. So basically, except for the COLA models, there are two models from COLA that are the warm outliers. But there's no model right now that predicts anything seriously in the El Nino territory. Next. Okay, so what else do we have? Because really, we always talk about El Nino, La Nina, and it has been with us for 9 winters in a row. So this is the first time since 2003-04 that we are looking at a neutral winter. So we have to look at other things. And of course, that's my business anyway. So another factor to look at is the Pacific Decadal oscillation. Basically, we are in a stage right now where it's cold in the northeastern Pacific all the way to Alaska, and it's warm off the coast of Japan on the Kuroshio. And it has been so extreme. In September, it reached a value last seen, I think, in 1933. I think Vic mentioned that once before. That if you look historically at cases where it was below minus 0.5, and this is a normalized value, in the spring and summer, those are all these dots there, it has never come up above zero except that one red box there, that was the fall of 1972. 72 was also a fairly strong El Nino event embedded in these negative PDO conditions in general, I mean, except for that fall season. So in other words, even though we're not doing operational forecasts for the PDO, it's a pretty safe bet that it will remain negative because it's just so negative going into the season. And, you know, it likes to repeat itself from winter to winter, and it was negative last winter too. Next. So what's the difference? Well, if you have a neutral answer condition and negative PDO conditions, that's the panel on the left. Those are the cases from October through March. And the bottom line is it looks kind of dryish. Now, these colors are not very strong. We're talking 0.3 to 0.5 below zero for the standard deviation. And in my book, when you have this many cases, about 0.5 is a cutoff where statistically you have a significant tilt. This would translate like in the CPC business, you know, you would talk about if it's 0.5, it's like a 43% odds of being in the lower tercile. So this would be, if you converted this into a CPC forecast, it would show brownish with maybe the top contour around 40%. Now on the right, you can see those 5 cases that I have where we had an El Nino of at least some strength with the negative PDO. So this includes 72, 73. That is really good. That would have been really good news for the Southwest. I mean, those blue colors, actually, when you look at the numbers, they were above +1 standard deviation. So this is the kind of figure that makes skiers drool in our neck of the woods. But obviously, that's not in the car anymore. But for Oklahoma and Texas, the difference is not that drastic. It's huge for California, for instance. But for Texas and Oklahoma, I could say Oklahoma maybe would have looked a little bit better than Texas on average. But again, that right panel, I'm just showing that for illustration that this is the kind of scenario we were looking at 2 or 3 months ago, and I think it's extremely unlikely now. Next. So then there are other factors. And last week in Abilene, I got a little bit into the details of where we are at in terms of predicting the state of the NAO. It's essentially a weather phenomenon that doesn't seem to be predictable beyond 1 or 2 weeks, and people are trying, and I think it's very much worth the effort. If you look at the circled area in Texas and Oklahoma, the difference between a positive NAO and a negative NAO, so if you would do a difference map between the two, would be quite drastic. This is using answer-neutral background conditions. And then we saw this last year too, even with a La Nina, we had extremely positive values in the NAO, and I think that was a big factor in keeping Texas wet. So in other words, if we end up with a negative NAO this year, that's another nail in the coffin, if you will. That's another argument to say that we should hedge towards a dry winter. If we get positive, then those faint colors, that's a plus 0.1 to plus 0.3. So that's not really, if you try to hang your hat on that, it would probably fall off the wall. But at least, the difference is still significant. And I have this little red statement here that we had the 5th highest increase in snow cover in Eurasia last month compared to September. This is for the last 45 years or so. So Judah Cohen, I think at some points we're going to come out with a statement saying that his October Snow Advance Index, which he published last year, would predict a cold winter in Europe and in the eastern U.S. and basically a negative NAO. We'll see what happens. Next. So what are other factors? Well, I mentioned already the PDO. There is some modeling evidence that Sieg Schubert and about 20 other people summarized in the Journal of Climate in 2009. If you put basically a negative PDO condition into the models, so you're driving the atmospheric models with sea surface temperatures that are typical for a PDO La Nina setup and the warm North Atlantic, then all 5 models that he looked at here have those big blue bars, which basically indicate a dry U.S. footprint. And if you actually do this, I actually normalized the PDO and normalized the AMO and took the difference and then ranked these and looked at the low cases, the next figure. So those are the cases there, 1948, 50, 52, 55, 61, 98, 99, 2001, 2005, and 2008. It turns out that so this is for concurrent conditions. So if you have October through December values of that index that are low, you get the footprint that you see on the left. In September, and actually if you do the same for the summer, the value that we had this summer in 2012 was the lowest on record in over 100 years. Again, with the PDO the way it is and the North Atlantic being warm, unlikely that we'll see a reversal anytime soon. So I think we can bank on a negative scenario. And that's not good news for you. And so far October obviously has borne that out, that we haven't seen a wet October. So I think this is a pretty robust signal there. That red is reaching almost -1 standard deviation. On the right, I have done the same exercise if you have very low values of this index in January, March, so those are not exactly the same years. There's an overlap, but it's not the same years. And it gets a bit weaker. That signal is not that strong in the winter. I didn't bother to show you April through June, but in April through June, it also goes dry again. So this is the overall condition that people have talked about, that if you have a cold North Pacific and a warm North Atlantic, that's just not a good setup for us. It's very hard to get out of that overall condition. Next. So here's CPC, and I think it was mentioned before, there has been a big change. If you compare on the left the September forecast made for October through December, which is often the input that is then used to make a November forecast, and you can see what the November forecast was a week ago. This is the updated forecast. It's essentially a reversal. I mean, it's right on the coast, there's equal chances, but for northern Texas into Oklahoma, they have it dry. So yeah, there's nothing left there of El Nino. Next. And the same for the forecast for January, February, and March. On the left, there was still hope, springing eternal, that El Nino might come to the rescue. And on the right, that's I would call this a hedge. There's a little bit of trend in there, but what you see there, those colors are consistent with El Nino if it were to come back. And my guess is that the new forecast that's going to come out next week will probably even whittle away at that. I don't think they can justify even that unless the trend is that strong. I haven't checked the trend on this. Next. So I have been producing statistical forecasts that are, I don't have time to get into this, but these use influences like El Nino, La Nina. They also look at temperatures in the Gulf of Mexico and more remote teleconnections, for instance, to the NAO preceding the season. And so this is a forecast. This is my first forecast I issued back in April. And I had high hopes that western Texas at least would get some moisture, and I went dry in eastern Texas into Oklahoma. And you can see CPC had a forecast that was dry over the Intermountain West and then on the coast of, on the Gulf Coast in Texas and Louisiana. And I guess suffice to say, basically any red or any brown forecast verified and the green ones didn't. Now CPC, to its credit, didn't have any green. And you can see in southwest Texas there were some spots where it got wet, but it just wasn't enough. Next. I'm pretty happy about this forecast. If I could just edit out that last week in September, it would have verified even better. We had that one remnants of a tropical storm that went through Texas last week of September and kind of ruined the forecast a bit. But the pattern of dry in western Texas, New Mexico, into Oklahoma, and went towards the Gulf Coast, I think verified pretty nicely. So I'm going to keep that as a slide for saying, hey, this is how good we can be. And you can also say that this is the case where CPC guessed wrong. Next. So this is the forecast I issued actually in September for October, November, December, and again, remember these are forecasts I've just started making this year, so I personally don't have a good feel for how good they are. I have been checking in the records, I've done cross-validation, but I found that when there's nothing that beats the actual field experience of running these forecasts. So right now I have a mixed forecast. In general, October through December is the worst season of the year to predict. This is actually true for my forecast as well as CPC. It's just a tough season. So that's why I have these question marks. They actually mean that there are high chances for either extreme rather than being near the middle. So that's my first, it's not equal chances. But I have a little bit of red, unfortunately, in southwest Texas and in Oklahoma. And I had this interesting bullseye over the panhandle of Oklahoma. And if you look at the verification so far, right where the W is, in the panhandle of Oklahoma, there was apparently one event, I guess that was in October, that was wet. Well, we'll see what happens. I'm not willing to write off my forecast just yet, because we might still get some events in the next. Next. So here's my summary. Neutral winter, first time in 9 years, 2003-4 was the last time. This means that basically you have more uncertainty. I think that's where I agree with Vic's statement. If we were to get more active intra-seasonal oscillations, that would be one mechanism by which you would get more extreme swings in the weather. It also would open the door to some rejuvenated El Nino condition, although I think that's pretty unlikely. In general, if you have information on the NAO and the PDO-AMO, we have officially done, the United States does not make any forecasts, as far as I know, at the government level for both of these features. Of course, Decadal predicts the NAO essentially, but we don't have any CPC forecasts as far as I know. I think it would be quite helpful, and especially on the longer time scales. It seems like the PDO-AMO seems to be really the thing to key in on if you're trying to predict multi-year droughts. This winter, I think it's a safe bet we'll see negative PDO conditions, which is not a good setup, even with neutral ENSO. And with the Atlantic, if it stays warm, that would reinforce that dry signal. If we get a negative NAO, so Decadal is right, that would also make it drier. my own statistical forecast just for October through December, and I will do an updated winter forecast at some point in December. I have some hope for the Texas Panhandle region, but otherwise I'm very agnostic on that. I mentioned El Nino possibility of a comeback. Again, every week I look at this, I get a bit more resigned that this is not likely. I think we're running out of time here, so maybe for another month or so we have a shot. If this MJO that's coming around right now, it's for the maritime continent. If it somehow gains strength and holds together into the Central Pacific, that's sort of the one shot we have that it could still rebound into El Nino. And that's all I had. Thank you.
Well, thank you, Klaus, and also to Victor and Brian. I think we've seen the difficulty in this year with the challenge of the forecast for El Nino and going to neutral and how many other things have to be considered. We do have a couple of state climatologists, I believe, on the line. We're going to begin Gary McManus with Oklahoma to give an update. Gary.
Thanks, Mark. Let's get away from El Nino madness here for a little while. Let's talk about what's actually happened here. Oklahoma, the story is pretty simple. It just hasn't rained in a long time. And of course, we now see that drought start to advance once again across the state. It hasn't been a large jump in the last week. It was just about 8% of the exception or extreme to exceptional. I will say we're lucky that we're into the cool season. If this had happened back in August or September, we would probably have a very large increase in that statistic. So we're lucky we're in the cool season when it can't quite advance as rapidly. Next slide, please. And here's the story, plain and simple. You can see across much of northern and western Oklahoma, it's been from 40 to up to 55 days. And we'll add a day, add a day, of course, it would be up to 56 days without a single day with at least a quarter-inch of rainfall. As I said, we are in the cool season. We have had some really warm temperatures during this time, though. We have had a lot of wind, so that has caused that drought to advance once again. This, of course, has affected agriculture. We have very bad reports over the last couple of weeks on our winter wheat crop. It's starting to go downhill pretty rapidly. The canola crop, the same thing. And, of course, we still have very bad conditions with our stock ponds and our reservoirs, which I can show you on the next slide. Our major reservoirs across the state from the USGS conditions. Percent of capacity, you can see we now have 11 reservoirs, major reservoirs across the state at less than 70% capacity. Those in the western parts of the state are the ones that are way down there below 50%. Lake Altus, which is a very important reservoir for cotton irrigation, for the second straight year no water was released or very little water was released. Those are the areas that have been in drought continuously for 2 straight years, going on more than that now. So we have both short-term and long-term impacts affecting Oklahoma right now.
All right. Thank you, Gary. I think John Nielsen-Gammon might be on the line. John?
Good morning. How you doing? Just a brief update. I think pretty much the material's been covered. We've been a little bit better off than Oklahoma, but not a whole lot. And October is climatologically the 3rd wettest month of the year, and we're coming in one of the driest Octobers since the 1950s. So we're definitely concerned about what this means for a 3rd year of drought in much of West Texas and part of South Texas as well.
Right. Thank you, John, and hopefully we'll get that little boost that Klaus was talking about, because I think you really saw that in Texas, what that would do. Do we have any other state climatologists on the line? Okay. I guess that's it. I don't see any questions posted there, so I'd just like to remind everybody that a lot of these resources we do have posted online. This video now is online on the SCIP website, southernclimate.org, as well as a YouTube site. Also like to point out that we have a newly designed U.S. drought portal. Drought.gov has kind of rearranged some of their materials there. The webinar recording will be posted to the SCIP homepage here shortly, and we will produce a summary of this and post it on the SCIP website as well. We've been recording weekly 5-minute weather briefings or drought briefings each week and posting them to the SCIP homepage and to YouTube. They appear usually Thursday afternoons or in some cases Friday morning. If you have any questions or need assistance dealing with the drought or other types of hazards, please contact us at SCIP. Thank you for your time today. We look forward to continuing this conversation with you in the future. Have a great week. Thank you. Oh wait, I'm sorry. We do have a question here posted from Albuquerque. The references for the individual presented the ANSO modeling for Klaus. We will post that, and the webinar itself, the recording will be posted, but we'll pull the links out of there, and we can send that out as well. So, and Klaus, I think if you're still on, do you have the link to the MEI, your website?
Yeah, it has the website. I think it has, I'm not sure about the European model. I can send you, maybe I will send you the links for the European model and the IRI. I mean, if you Google them, they're pretty easy to find, but might be easy to have them all in one place. I don't know what she meant with references, actually.
Okay.
Do they, you know, my advisor is still alive.
If you maybe if you could type in your into the chat box, type in like where where you have your information, the MEI information, the URL that might.
Okay, I will do that.
Yeah. Okay. I guess that's all we have. So again, thank you for participating in this, and everybody, we hope you have a great week. Thank you.